Hi team, this is Craig with the second lecture in our nutrition series following carbohydrates. Our second macronutrient group that we'll talk about is protein. So we're going to cover some protein basics to start with. We'll look at the types of protein that we find in our food, some of the key functions of protein. This will be a little shorter, this lecture, than carbohydrate, because while protein has a bunch of functions, we typically get enough in the Western diet, particularly here in New Zealand, so it's not usually a critical point of discussion with nutrition. However, it has some applications in some certain areas like exercise performance and weight loss that we need to be aware of. So let's crack in. So firstly, what is protein? It is a complex organic compound, which means it effectively comes from real living things, and its base is a chain of amino acids, as I'm sure you're familiar with the term. It contains carbon, hydrogen and oxygen, which is similar to carbs, but the differential there you'll see between carbs and protein is the presence of nitrogen. And it's this presence of nitrogen that actually differentiates it not only from the other macronutrients, but actually the different proteins from one another. So protein, as we said, is made up of amino acids. They are the building blocks of all proteins in the body. There are 22 recognized amino acids, and they can be split into either essential or non-essential. And what differentiates those two is that essential amino acids can't be made by the body, so we need to supply them in our diet regularly. The non-essential amino acids can be made by the body as long as there's carbs, fat and nitrogen available to the body. You're not going to have to know the individual names of these guys here. You can see them listed, but there's no test or assessment based around your knowledge of the different amino acids at this level. I guess the easier classification for us than learning all the amino acids is the distinction between a complete protein food and an incomplete protein food. So a complete protein food supplies all of those 8 essential amino acids in one food product. You'll typically find them in animal-based products, and that makes a lot of sense given the human body is made of tissue, and that tissue is very similar to a lot of animal tissue, and we use a lot of the amino acids that we supply the body with to replenish, repair and maintain the physical structures of our body. So a complete protein gives you all of those amino acids that we need to consume in one handy package. So you can see there the different cuts of meat are all in there, fish is in there, and then derivatives from animals such as eggs, milk and milk-based products are also known as complete proteins. You can find amino acids in a lot of other foods. Plant-based foods do have amino acids, but don't have all of the 8 amino acids in one complete package. So those that don't supply all of the essential amino acids are known as incomplete proteins. Of course, you can combine plant-based proteins to form complete proteins in your diet. So vegetarians, as long as they have a selection of different plant proteins in their diet, should be able to get good coverage of the essential amino acids. Nature's been somewhat handy in that process, and the colour combinations that you can get with vegetarian or non-meat eating sort of helps you along the lines of finding a collection of amino acids. So if your colourful plate consists of a red, a green, a yellow, an orange, that kind of thing, at least 3 to 4 different colours, then you know that you're getting different forms of amino acids from those foods. So its functions. Now, carbs, which we talked about in the last lecture, they had a simple function really, and that was energy, full stop. Protein has a vast array of functions in the human body, and we'll dive into them now. The one that most people are aware of is the top one there, growth and maintenance of body structures. So physical parts of our body need to be remodeled, they need to be maintained, and sometimes need to be added to and grown, obviously as we go through different phases of our life and also within the goals of our sport. So we're talking tendons and muscle and the different membranes around the body, along with our key organs and even our bones. Amino acids are also turned into enzymes. And enzymes, we've been discussing their role in previous lessons around the breakdown and digestion of food. So these proteins facilitate chemical breakdown either through saliva or through the different enzymes and acids that are found within our digestive system, which assists with the breakdown of food and therefore makes food more absorbable into our system. Proteins are also turned into hormones, which act as chemical messages around the body. They regulate our body processes, including growth and tissue regulation. Antibodies formed from amino acids protect against foreign invaders and disease. We have plasma proteins that assist us with electrolyte balance and also our temperature control. And typically you'll find proteins, dissolved proteins, floating in your plasma. Acid-base balance, obviously keeping the body at a neutral state so that we don't get too acidic or we don't get too alkaline. And protein can break down into these buffers, which stop us getting too acidic. Transportation, anything that gets carried around the body in the bloodstream or any other transport system within the body is essentially carried by a protein molecule. So we're talking the oxygen carrying, we're talking the CO2 carrying, we're talking, as I said, heat. All have a protein carrier associated with them. And then finally, at the bottom, energy. And there is a reason why energy is at the bottom, because it's actually not something we want to encourage, the use of protein for energy. If we are providing the body with energy from our protein stores, then our protein is not available to do all of these essential functions that we've just listed above. And that's why we typically would prefer to use the other energy sources of carbohydrate and fat to provide our energy for daily activities. Most of you are going to be pretty aware of where protein comes from in your diet. We're very aware of the meat and animal-based sources that are listed here. So all of the key meats and fishes you'll see up here, along with the derivatives from milk, cheese, yogurt, etc. Then you've got your plant sources as well, nuts probably being the highest in protein out of these sources here. You've got your substitute type proteins as well, the soy-based things. A lot of the vegetarian products that are soy derivatives would have some decent protein in them too. Not up in the sort of same potency as the animal sources, but still good sources nonetheless. So it is quite hard to keep the protein levels down in a diet, because when you combine a lot of these grains, even some of the vegetables and so on, along with these meat things here, you can see it climbs pretty quickly. So we'll do some work on how much protein is yielded from different sort of food products that we eat in future lessons, and you'll see that pretty quickly people can achieve their daily recommendation. And then in Western culture, in New Zealand, in particular, with an abundance of livestock that we have here, meat's pretty easy to come by. So a lot of us will be regularly over-consuming, even double or triple our protein needs. And that does bring with it some problems for active populations, where the majority of our energy for exercise needs to be derived from carbohydrate. And if you're constantly filling up with protein at every juncture in the day, then your appetite is going to be suppressed somewhat, because protein is something that we know keeps us fuller for longer, and therefore you may be at risk of not eating enough total energy or not eating enough carbohydrate to fuel exercise effectively. And if that is the case, if one of your goals is to build muscle tissue or to perform at the highest intensity that you can, you may actually be handicapping that process by over-consuming protein. More on that later. So we'll look now at how protein makes its way into our body and how we can then utilize it. Particular emphasis here on the storage of protein in the body and the places in which that occurs. So first, we've got to digest it. We've got to chuck it in our mouth. We've got to chew it up, and that will start the process of breaking apart some of these amino acid clusters that are found in particularly the meat products that we eat. The saliva will moisten that food and will also start some of the chemical breakdown processes, which take a bit longer than carbohydrate. In the stomach, Stomach acids will work to uncoil these protein chains. Enzymes are activated to go to work to actively break down these chains and try to separate these amino acids into their amino acid forms. In the small intestine, we're continuing to break down these protein structures into their amino acid form. And that can take anywhere between 1 and 4 hours, depending on how much food you've put into the stomach in one go, and what else it's mixed with. We can also either aid or detract from that timeliness of the emptying of the stomach. So this figure doesn't look like very much. Pure protein in the body accounts for about 17% of your total body weight in a let's say a normal sized person, someone who hasn't got an overabundance of muscle on their frame. Doesn't look like a lot, but when you consider the body is conservatively 60% water, a little less conservatively, between that 60 and 70 mark, you add in your bone weight and then of course your body fat percentage, and that's really the number that's left when you think about the actual physical structures of the human body. So muscle, of course, weighs a lot more than 17% of your body weight, but only because it's full of blood and other electrolyte substances. So if it was a dry weight, we're looking at roughly 15 to 20% of your total body weight being actual protein. In order for our body to use protein, it has to be broken down into its amino acid forms. It's then absorbed through the walls of the small intestine in exactly the same process as the carbs are absorbed through. And just like carbs, the next stop is the liver, where not only is the blood cleansed of impurities and toxins, but this is where the amino acids are stored in amino acid pools. And there they are ready to be distributed to the body and converted into different things that we need at different times, including the enzymes, the hormones, and of course the muscle protein that we need to maintain our current structures. When other energy stores run out, and we're particularly talking about carbohydrate here, amino acids can be utilized for energy. Most people are not geared up for maximum fat utilization during exercise. You're talking higher end athletes that have a system that can really access fat stores and use them to prolong their carbohydrate storage so that energy can remain in those higher intensity endeavors for longer. But in most people, we chew through the carbohydrates quite quickly. Then we look for the next most easily accessible energy source, and unfortunately, that is our own tissue. So through a process called gluconeogenesis, we break down the physical structures of our body to actually utilize as energy. And of course, that's not a desirable thing. I don't know anyone really that sets out to do exercise with the goal of reducing their muscle mass. It's not usually a goal that you'll hear in a gym-based situation. People say a goal of losing weight. Well, if you said to them, do you mean fat or do you mean your muscle? I think most of them would say my fat rather than their muscle. So we've got to view that as kind of a negative outcome if we're starting to chew through our protein reserves to fuel exercise. Now, different protein foods that we eat will absorb at different rates, and this goes back to complete versus incomplete proteins. Of course, your body is going to recognize physical flesh and tissue. We're eating the muscle of an animal to build the muscle of a human, and there's a lot more likeness between the meat that we're eating in our own body tissue than what we eat in a plant. And that's why the absorption rates, the amount of protein you actually absorb per unit of food is much higher from an animal context than a plant. This little picture here just runs through the passage of protein. You can see the amino acids are absorbed into the portal vein here and sent off up to the liver before they're put in those pools and circulated out for their roles. And then down the bottom here it says little dietary protein is present in the feces, which means yes, you can overeat protein, and if you do overeat protein and there isn't a need for that protein within the body, you will convert it to fat and store it as excess calories that way, the same as carbohydrates. So the more you eat, the more is going to stay in your body. You either have to have a use for that, or it will be converted into fat and stored as excess calories. So this just shows the process here. We eat proteins, we break them into amino acids, take them to the liver where they're put into the amino acid pool, and then they're sent out for a variety of tasks, including the ones we've already discussed. They could be converted to glucose for energy, or they could be stored as fat if there isn't a demand for their services at that point. We also get a little regenerated cell protein, so from cells that might have broken down, we can regenerate them back in the liver here and add them back into the pool as well. So your 3 key storage places for protein in the body, these are the ones we need to know, so make sure you highlight this in your notes and be ready to answer this come exam time. Protein is stored, just like carbs, in the liver as muscle tissue, and any excess is stored as adipose tissue under the skin, so that's body fat under the skin. A couple of terms before we move forward. For those that are interested in supplementation and have a protein shake or something like that, and you're looking at protein powders and you're thinking, well, do I spend the money on this one, or is this cheap one any good? Things you should look out for when looking at protein supplementation is the quality of the protein. So first of all, does it come from a complete or incomplete source? Is it derived from a milk or animal-based source, or is it derived from a plant source? That will definitely determine in some part the absorption rate of the protein that you have. You then look at the BV, which is the biological value. The biological value of protein is really measured by the amount of nitrogen that is produced from the absorption of that protein. So nitrogen is that factor that we said differentiates protein from one another and also from the other macros. So you see down here the term nitrogen balance. Well, an easy way for a medical professional to determine whether someone had good nitrogen balance, so let's say one of your goals was to build mass, you would want to be in positive nitrogen balance, meaning you're eating enough protein. When we have slightly excessive protein going into our diet, one of the waste products that we excrete through the kidneys is nitrogen. So it would show up in your urine, and if you had increased amounts of nitrogen in your urine, one or two things would be happening. Number one, you're either slightly over-consuming protein, which is, I guess, the preferred option to under-consuming if you're trying to build mass, or two, for some reason your protein stores might be being diminished within your body, and you're peeing out obviously the waste product of that. So yeah, you would either be in positive or negative nitrogen balance depending on how much nitrogen was present in your urine. And we'll talk about this briefly soon, but there is some link between excessive protein intake and kidney damage, and largely that's been blown somewhat out of proportion. You have to eat a large amount of protein, an excessive amount of protein over a prolonged period of time to put that sort of pressure on your kidneys, but it relates to this nitrogen balance where the nitrogen is a waste product for the body, and the more protein you eat, the more nitrogen you produce, and therefore the more urine production occurs to get it out of the body. So if it was becoming routinely excessive, then you could place your kidneys under a little bit of additional stress. So a couple of protein facts going forward. Protein needs definitely vary for individuals, but if you look at a typical population group, then around 12 to 15% of the total calories consumed as protein would be about the right number. In a healthy diet, all you need to maintain the tissue you have is about 0.8 grams per kilo of your body weight per day. So you'll notice that says for non-athletes, so this is just for sedentary folk. Now you take a small sedentary person, someone in, around that 50 kilo, 55 kilo mark, a lot of smaller framed females might be in that bracket. That allows you only around 40 grams of protein a day to maintain your needs. And you can see how easily you could go over and above that. 100 grams of most meats, our chickens, our beefs, etc., would yield about 30 grams of protein. And 100 grams is not much. If you think of the weight of a pot of yogurt at 125 or 150 grams, that much meat effectively yielding almost the entire day's requirement for protein. And then you add your breads and your milks and your other things you eat during the day, and easily would probably consume over double what your protein needs are. Now for athletes, it's a little bit different. Athletes have a greater requirement for protein because we cause more, I guess, conscious breakdown of tissue through the exercise we do. The harder you work out and the more micro damage you do to muscles through training, then the more protein you're allowed to repair and replenish. And it's that simple philosophy, Wolff's Law, which is, if you effectively damage something or put something under stress, then it will repair itself in a fashion that will prevent it from being damaged in the future. So by putting the body under stress, whether that be bone or muscle or anything else, it will try and regenerate and improve that muscle or bone so that when put under stress again in the future, it's better equipped to deal with it. And the happy bonus of that, I guess, for the athlete is an increase in bone density and an increase in muscle size and mass. Just a reminder that when you're eating plant-based proteins, if you're not engaging in meat eating, then a combination is really important. So a combination of grains and then a combination of colours on the plate. And as many colours as possible in a sitting would be beneficial. And then we recognise there are special groups that also require extra protein. We've talked about sports people, but also pregnant women. You're effectively growing a new ball of protein within yourself. So the baby is obviously going to steal the nutrients from the mother, etc., to fuel its growth, and therefore the pregnant woman has to allow for that with some additional protein in their diet. And similarly, a child right through their adolescence into adulthood is going to continue to grow, so would need protein levels above and beyond what a fully mature adult would need just to maintain the tissue they have. So is a high protein diet a good thing? Well, you've got to temper that question a little bit with, well, what is the goal of the person? If the goal of the person is energy for activity, then probably not, because we know that most of our energy is derived from carbohydrate for intense training. So protein could effectively get in the way of consuming enough carbs, and therefore we would then encourage use of protein as an energy source, which is actively working against what we're trying to achieve in, say, a gym situation or a muscle mass growth situation. So with a high protein diet, your energy may actually result in decreased performance as those carbs are sacrificed for the protein. And that protein fills you for longer, meaning you're not prompted to eat maybe the amount you should. Now that could have a positive effect for someone who's trying to limit their calorie intake or reduce their weight. We're then going to look for, most parts of the day, a way of eating that can keep us fuller so we consume less calories. And protein can definitely be used in that instance. We can manipulate our diet and the percentage of calories that protein makes up in our diet based on our goal. And we'll talk more about that soon, and we'll actually do some calculations for different population groups with different goals, and I'll be showing you how to manipulate the figures that you choose for those people based on their goal. We mentioned about the kidneys before. Like I said, a little bit of scaremongering goes on with this one. You would have to be eating, like I said, an excessive amount of protein over a considerable amount of time for your kidneys to run into trouble there. People on a high protein diet that get their calorie intake wrong can lead to weight gain, because while protein is found in a lot of good lean produce and meats, it's also found in high amounts in less quality foods. So it's really important we try to wherever possible, eat quality proteins coming from whole foods if we can. You get a much inferior product when you start, taking something like good quality beef and turning it into a sausage and then using a lot of fillers and things like that. You'll find the meat quality or the meat percentage in those kind of meats drops significantly, and therefore so does the protein. But the fat that is used to pad out the protein raises the calorie content of that. So we're basically saying, if you're choosing to eat most of your protein from processed sources, then you can almost guarantee that's going to be higher in fat, which could lead to excessive calorie intake. With the additional urine output that you might experience with an excessive protein diet, it's not only the nitrogen that gets excreted, but other essential electrolytes can also leave in urine as well, and one of those is thought to be calcium. So there is a link between excessive protein intake, the increased urine production, and that of calcium excretion from the body as well. So could lead to a reduction in usable calcium within the system, and therefore a depletion of your bone, so a struggle to maintain the bone density you have. You might find as well, as if you are choosing poor cuts of meat or processed meters we talked about before, that the cholesterol levels that you experience might also rise. Okay, so it's not a free-for-all buffet. When you say a high-protein diet, it's just not gorging on as much meat as you like. It has to be within calorie boundaries, and there are still some other considerations around fat that you have to make as well. And just one last point down the bottom there, it's really important that we make people understand that there's not a direct correlation between eating lots of protein and building muscle. It's not a direct correlation. I'll say that again. The more protein you eat, the more you grow is simply not true. You need to eat the protein required to facilitate muscle regeneration and repair of tissue. Okay? But if you overconsume protein, you will most definitely store the excess protein as fat if there's no need for it in the body. The thing that creates muscle growth is not protein, it's the training. And the thing that drives the training is carbohydrate. So again, you would need to be, if you want to make muscle, we need to do more training, we need to eat the carbohydrate that facilitates that training, and then we need to make sure we eat our protein in the right windows of time to encourage the regeneration of that muscle tissue, which will lead to growth. Not so much an issue in this country. In Western populations are diets that are severely low in protein. There's a couple here on the page, and we won't spend a lot of time on this because it's something you'll have little to deal with, I'm sure, but you can appreciate, I guess, why it is a concern in the overall scheme of things and worldwide. So kwashiorkor, these guys here, you often see these little guys with living in these third world countries with these bulbous sort of tummies here. Now these guys actually do eat enough in terms of calories, but they're almost exclusively eating carbohydrate from maize or staple grains. And what we know about that is if you're not full and you're eating a lot of these grains, then 1 gram of carbohydrate that's stored also stores with it 3 mils of water. So we get a lot of water retention occurring through here. Whereas in this one down here with marasmus, we have a deficiency in total calories. So this is where the absolute skin and bones comes in, where the body has utilized its own muscle tissue. Or in the case of a child, never really had a chance to produce muscle tissue in the form of muscle protein because of a lack of sufficient calories and, of course, a lack of protein. And it's not only going to affect the muscle tissue here, but obviously we talked about all the transport roles that protein plays in the body, and that means a lack of transport carriers for things like oxygen. And once we get sick, our immunity is impaired and all those kind of things because protein plays a huge role in antibodies and things that fight off diseases. So we're very lucky in this country that we don't have this. In fact, we have the opposite problem, which is more around overconsumption. And just finally on these special topics here, we've talked about vegetarians, making sure they have a mix of different vegetables and grain-based proteins at their disposal. There's a few ideas here that you'll find in your notes as well, but these are I guess some of the top non-animal protein sources. You can see a cup of tempeh there at 41 grams of protein is pretty similar to what you get from an animal yield. So look out for these things if you are a non-meat eater, and just make sure we're getting a good range of these things. It's very easy to stick to the same staples, and that may mean that you're missing out on one or more essential amino acids. So making sure we get that good colour scheme going, not only from our vegetables but also from lentils and our beans and some of our key grains there as well. Protein supplements. Many of you might be taking a protein supplement or thinking of taking one. My thoughts on protein supplements, they definitely have a role. I think their role is post-training and should really stay at post-training rather than being consumed instead of real food at meals. I'm not a huge fan of meal replacements and things like that. I think the body responds a lot better to whole foods and real foods. But post-training, there's that window of opportunity there to maximise our recovery by making sure we have a post-training feed that supplies the body with enough carbs and protein to really regenerate. And sometimes it's easier to have something in a supplement form that's there and ready to go immediately upon finishing training rather than waiting an hour or two to get home and cook something up and that kind of thing. And the longer you leave it, the more chances you are going to succumb to hunger and eat things that are not going to enhance that process of recovery. So, yep, I'm certainly a user of protein supplements, but only around the time of exercise. I don't think it should be something we're just sipping away on during the day. The best forms typically would be from milk. So you've got the milk fat portion, I guess, which is the caseinates. They tend to release a little more slowly. So a lot of bodybuilders and people that are looking to retain their muscle mass when they've got quite a high metabolic rate due to the amount of muscle carrying, will have one of those at night so that it ticks away and keeps replenishing muscle. You've got whey, which is a very fast releasing protein. I guess very similar to the simple carb of carbs. Whey in whey powder form is very quickly absorbed by the body and therefore gives you very quick access to it post-training. You've got egg-based and soy-based, which yield about 95% of what we get from our whey, etc. So pretty good options there. And there are also some lactose-free ones that are coming onto the market too. Alrighty, so what do we need? That's the next step, working out our calculations and what we actually need to get into our body based on our exercise regime, our current lifestyle. So this little table shows it relatively clearly. You should be able to work out where you fit on the scale based on the amount of exercise that you do, but we'll simplify things and state, first of all, if you're 18 years old or younger, then you're still classed as an adolescent. And you get the greatest intake of protein yields here, 2 grams per kilo. You can see at both ends of this table here. So 2 grams per kg of your body weight will be enough to maintain the tissue that is still growing. So you shouldn't really say maintain when we mean actually continue growth. The average adult, like I said before, sedentary adult, 0.8 grams per kilo seems to be enough. Bear in mind we might increase that figure if we have a weight loss goal there. So we might increase that figure up to take a larger chunk of the calorie portion of the day to make sure that person stays full. Doesn't need a lot of carbs in particular. If they're not athletic or they're not training, then carbs can play a much smaller role in their life. We need to keep them full and keep the calories down. Pregnancy, like I said, a little bit more. And with this one, unlike the carbs calculations that we did, I'm always more prone to go with the higher number here. So 1.2 for the pregnant woman. And then you've got an active person here. So this is someone who does something on a regular basis, whether it be a light jog, whether it be walking the dog, that kind of stuff on a daily basis, at least 1 gram per kilo. Now, most of the guys in this class are obviously going to be working out in a more structured fashion over the course of a week. So to be classed as endurance, you would need to be doing, 4 sort of endurance-based activities a week. And that could include sports, basketball and rugby and hockey and football. They're all endurance-based sports where you do a lot of running. So if you're involved in those kind of things, 3-4 times a week, then class yourself as endurance and take 1.4 grams per kg. If it's 3 times a week, you might go to 1.3 or 1.2. To be classed as a strength-trained athlete, you need to be doing 4 meaningful sessions of weights at a reasonable intensity for at least 45 minutes at a session every week. And if that's you, then you can go straight to 1.7 grams per kilo, which you'll see is the largest of the non-adolescent or child values that are on the table there. If you do 3 or 2 weight sessions a week combined with some endurance in that, then just moderate that down a little bit towards that 1.5, 1.4, 1.5 mark. Okay, so we'll do obviously more work on this in class. You may have already worked through this in class, but just to reiterate those key points there. So you'll do your math on that one there, and let's say you've got an 80 kilo male, and he's doing a couple of sports practices and 4 weights a week, and you think, well, is he endurance, is he strength? Well, do we add the 2 together? The answer is no. You take the higher of the numbers. So if we're doing sport and some endurance stuff, but we're still getting those 4 weekly sessions of weights in, then 1.7 is the figure that we're going to be choosing there. Okay. Now, as discussed in carbohydrates, we could also choose, if we're looking at a weight loss situation there, to reduce our calories or increase our calorie deficit by using our goal weight as opposed to our current weight if we're looking to lose a meaningful amount of weight there too. And that's another way of creating a little bit more calorie deficit in the diet. So just to wrap up, endurance athletes, you'll notice them, their body types are pretty thin, okay? They have pretty lean muscles, and that's usually because they will run out of carbohydrates on a regular basis when they run for their 1 hour or 2 hour runs or 90-minute cycles or whatever they're doing. And of course they run out of their carbs, their body turns to protein as a fuel source to get them through. General training, just when they're in a phase of training where I guess you'd call it easy training, slow longs, those kind of things, 1 gram a day is sufficient. If they're into heavy training phase and they're starting to sort of push up, then protein gets to go up with it. So it really could be determined by the amount of soreness you're feeling. You know, when you start a new phase of training and the legs get more fatigued and that kind of thing, then the protein can up alongside that to make sure that you have sufficient recovery there. Extreme exercise loads, we're talking, you're building up to a marathon, you're building up to a triathlon, you're building up to a coast to coast or something like that, and we can increase our protein right up towards that 2 gram per kilo mark in those extreme load situations. So typically endurance athletes don't eat enough protein. They're very carb focused because they know the benefit of carbs to their exercise, and they're all about getting the fuel in that's going to get them through the exercise at a meaningful intensity, and they know that protein is not that fuel. So they need it for their repair, energy, and recovery. And then on the other side of the coin, you've got the strength-trained athlete who typically eats way too much protein. Okay, now carb requirements, sure, for a strength-trained athlete who does no cardio, are not as high. So people may argue, well, they don't need as much carbs, so naturally they're going to have to eat more protein to get the calories in. Remember, the training they do does still need carbs, okay? So we've allowed for the additional protein with the 1.6, 1.7 grams of protein, which when you do the math and you get a larger guy, let's say you've got a guy topping 100 kegs of muscle, you're talking 170 grams of protein there. So when we talk about meat intake, that's definitely a couple of decent whacks of protein in their diet a day, whereas a normal punter at only sort of 100 grams of protein or something like that is only going to leave one decent meat-based meal a day, and the rest will come from the foods they eat. So there is that allowance for the bigger, more muscular person who does weight training to get that second meat-based meal in. It could also allow for something like a protein shake post-training, as I mentioned earlier. We use it for repair again. We use it for a small amount for energy and recovery, and it's worth noting that only a small amount is needed to increase muscle mass, and that's just, again, aligned with the amount of training and micro damage you do in the muscle. If you're predominantly a leg-based athlete or a powerlifting type athlete, then yes, you might need more than someone who just goes to the gym for aesthetics and does their curls for the girls and does their tricep stuff and their mirror muscles in the front. So someone using those larger muscle masses and really putting them through the ringer is going to need more protein to facilitate the repair of those muscles. So it's a minor fuel source, primarily used during endurance exercise when carbs run out. Its major role in exercise is for repair of lean body tissue in the post-workout phase. We see that different population groups require different amounts, from 0.8 grams at sedentary right up to that 2 gram per kilo in intense or extreme exercise loads, and of course the adolescent or growing person. And we need to understand that the average New Zealand diet contains more than enough protein already. So when we're analysing diets, this is typically not one thing we're going to have to increase in people's diets. It may be a case of actually cutting back a bit so we make sure that they're getting the energy requirements they need to maximise their training sessions. All right. Just going to put on this last point down here. Replacing red blood cells, etc. Just remember that protein has many other roles in the body. It's not just about muscle. We've got to get that context out of our head. It is important, sure, a small amount. It supports growing muscles, but does not necessarily speed up muscle growth just by eating it. Okay, so there are many other more important functions that protein is used for within the body. At this point in your lecture notes, you'll see the readings from the Australian Institute of Sport, and I'm not going to sit here and read through the same stuff that I've basically just told you, but there is one portion of this I'd like to look at, and this is this guy here. I'll just expand it a little. So as we look at this little diet here, it's the quantity of food required to provide the needs of a 70 kilo athlete with the amount of protein they require for their amount of exercise. So if you think of a 70 kilo athlete, let's say they're a sportsman, let's say they're getting that sort of 1.5 grams of protein per kilo of body weight. That's obviously going to take us just over 100 kgs, so about 100 grams of protein, 105 grams to be exact. And I just want you to note the way that protein adds up and the amount of food that you've got to eat to get it. And you'll see that it's not much. So we've got a couple of cups of cereal here, probably something like a Just Right or a muesli or an oats or something like that, yielding 6 grams. You know, a cup and a bit of milk, we're getting up over 10 grams there. A couple of bits of toast, there's another 10 grams almost. And then the first meat that we eat in the day could be a bread roll or a couple of bread rolls with about 50 grams of chicken. You know, it's nothing, with some salad and the bread. 40 grams of protein there, a little bit in the fruit here, a little bit in the fruit bun, some flavoured milk. And then dinner time, our secondary meat with, it's a stir fry with just 100 grams of meat, not going overboard there. And together with the vegetables, the pasta, that kind of stuff, another 50 grams there. A bit of puds with some custard, 13. And very quickly, we've added up to sort of 166 at 2.3 grams per kilo. So without going out of his way to consume protein drinks, or amino acid supplements or anything like that, this person's just eaten a normal sort of amount of food for a person of their size and easily has achieved their protein goals and some. You know, so there is a situation again where, depending on where training was, you know, did that person achieve the carb levels that they required for the day for the training that it did? You can see the snacks in here are predominantly carb based, but even them, you know, the yogurt there with up to 10 grams of protein in as well. And that's obviously quite a large carton of yogurt. That one, typically a pot will have more like 5 or 6. And we'll get to know what's in our foods, but I want you to realise that it's not just the meat that you're eating. You're getting protein from virtually everything in your diet. This thing goes on to show you some good stores for protein as well, some good sources, sorry. So you can see here, these things here in this table will yield you approximately 10 grams of protein. So you can have multiples of these kind of things here, and you'll see where the protein adds up. Okay. There's also some good talk here about weight loss and about, of course, utilising protein at the right times to ensure that you're getting the best out of your exercise. And remember, this is with an athlete focus. It's from the Australian Institute of Sport. So guys, that's protein. In a nutshell, we add that information to what we've learned from carbohydrates, and we have one more macronutrient group to go, and that is fat. And at the end of that process, we'll have not only a greater understanding of how all these macros fit in, how we should be utilising them around exercise, or as the case may be, not around exercise, and have a more complete picture of information going forward. Once we finish our macros, we'll then be doing some revision classes there where we look at case studies of different population members, and we'll practice these equations that we've done on ourselves at this point to make sure we're able to manipulate our macros appropriately for different population members to suit their goals. Thanks for listening in. See you in class soon.